conferences. CSI, ISTE, MTech, University Exhibition Trust for Tribals. Received Best Computer SDF. Nominated in ICT ACT Best Tech by ICT Academy of Tamil Nadu. Served as coordinator for Anna University of approved FDT and CSI and ISTE sponsored event and obtained topper and silver in NPTEL examinations and delivered many guest lectures in various reputed organizations. Resource person Dr.R.NIDHYA. Welcome, ma'am. You can. Yeah, ma'am.
Yeah, ma'am. Yeah, ma'am. Your voice is breaking. I don't know. It's a problem from my end or your voice is still breaking.
No,
Anyway,
ma'am.
good morning.
Your voice is clear.
Yeah, maybe problem at your end. Okay,
Yes,
ma'am. Let
ma'am.
it be.
Okay.
Good morning to everyone. As like ma'am told myself, Dr.R.NIDHYA, today we are going to discuss about introduction to machine learning and very few and simple algorithms regarding that machine learning part. I will show you. Ma'am, my screen is visible.
Yes, ma'am.
Okay. Okay, we shall start the session now. Today's topic, first session, we are going to discuss about the fundamentals of machine learning, what is meant by machine learning and what are the different types, what are the basic applications, what are the tools are there to implement the machine learning, the basic thing we are going to discuss in the first session. So we shall enter into the topic now. So the first one, before entering into our today's topic, I would like to give you the difference between these three terminologies. Anyway, these three topics they are covering in this particular FDP. Anyway, it will be useful for you. Maybe you are already aware. Still, I will tell you outline of what is the difference between these three terminologies. So AI, ML, and DL. So if you are considering AL, it is a big umbrella for the entire techniques. Why? Because in artificial intelligence, I'm trying to make a machine to think like a human. So if I want to make a machine to think like a human, definitely a particular one technology not sufficient to do everything, right? So on that case, to do this particular task, I need a n number of technologies to incorporate to derive my final output. So on that case, if you are seeing artificial intelligence, it includes machine learning, data science, and then what we call image processing, fuzzy logic. So like that, it is including n number of techniques. Okay, machine learning is one of the part of artificial intelligence. Okay, if you want to implement the artificial intelligence, definitely you are in need of machine learning to implement a certain part of the machine learning, artificial intelligence part. Okay, so let us come to what is mean by machine. That's why in the big circle we are putting machine learning, artificial intelligence containing n number of techniques to complete the task. Machine learning is one of them. That's it. So we shall come to the machine learning. So what is meant by machine learning? The name itself telling like machine is learning something. Yeah, it is right. Here what we are going to do is we are going to make machine to learn by itself. It is not decision making completely. It can't act alone or individually. So how it can act now when you are training for a machine to do a certain task, that task can be handled by the machine in later on days. Not immediately it can handle. You are going to keep on training to that particular task, a particular machine. After giving the enough training, you can give a certain test data to that particular machine, that machine can execute what is correct, what is wrong, or it can predict what is the final output maybe. So this is called machine learning. You are making the machine to learn something independently. Okay, so once you are training, after that you can use it at long time. It is not any restriction under. You can use it for a long while. Okay, when you are coming to the deep learning, so deep learning is a subset of machine learning. Even in machine learning also, you're having a number of algorithms, supervised, unsupervised, then semi-supervised, like that. So many things are there. In that, one important subpart is nothing but a deep learning. Hope you heard about deep learning. Deep learning is nothing but the name itself telling you. So machine learning, what we will do, we will have one input, one output. In between, we are finding a certain function mapping between the input and output. This is called machine learning. But when that intermediate function is having a 2 or 3 layers, on that time we can call this as a deep learning. What is the core concept behind the deep learning? It is the neural networks. Hope you people have heard about neural networks. The name itself telling you neural networks. What is mean by neural? Neural is the basic, what is the main part of the body? You can tell if you want to do some action, so I'm just moving the cursor here and there. How I'm moving. So something is instructed from my brain so that my hand is acting. That's it. So that's why we are calling CPU as the brain of the computer, right? So like that, brain, okay, we are telling brain is the important part in the body, but what is the basic component for the brain? It is a neuron, right? So that's why like neuron. So neuron is a network. So it is connected millions of neurons in the brain. So that neurons connected each other so that a particular input is given to that neuron. It is going to be analyzed by the neuron and it is going to give you a certain kind of output in terms of action for the human, right? Similarly, we are applying certain kind of human imitated neural concept in our computing technology that is called as a neural network. You will have a n number of hidden layers in that part. It is a really deep diving into the sea like that concept it is, so we can't touch it. But still, you should know something. Deep learning is a subpart of machine learning, which is working based on the neural network concept. What does it mean by neural network? Neural network is mimicking the mimic of human brain concept in the computing technology. Okay, so the neural is nothing but human imitation. Network is nothing but interconnection. So that only this is called neural network. It can handle a huge number of data in a multiple layers of hidden layers. You can get more precision when you are using that, way more accuracy in data when you are using a neural network. Okay, so these are all the three major parts in that current trending technology. What you are seeing in your 5 days FTP. Hope I am clear. So we will enter into the machine learning part. Ma'am, are you there? Excuse me. Hello.
Madam, can you hear me now?
Yeah. I can hear you, sir. Sir, suppose something going wrong, my screen is not changing. Now, please acknowledge me
Okay, madam.
because I don't know what's happening. Okay, thank you. So before we are entering into the machine learning, I just want to give you a certain difference between traditional programming, what we are studying in day-to-day life, C, C++, Python, whatever language you are learning. I want to give you the clear picture between the traditional programming and machine learning part. Okay, so because traditional programming also kind you are doing a certain program like addition of two numbers. Let me take a simple example, addition of two numbers. Let me take once I have done the program, whenever I'm giving the input, it is giving you a certain output, right? Even you are adding a 2 plus 3, or if you are adding a 5-digit number or a 10-digit number, based on the data type you have taken for the program, it will give you the answer. Suppose you are using a Python program, so it will not have any restriction. It will give you what is the maximum ability of that particular machine is designed for, or that particular program is designed for, right? So, on that case, how is the difference between traditional programming and machine learning? We should understand this part, then only we can move to further process. You see here in traditional programming, how you will do, first you will do a certain program like I told, like add of C is equal to A plus B, print C. Just we will take a simple side Python program, A is equal to 10, B is equal to 20, and C is equal to A plus B. Right, this is my program. Then while I'm executing my program, I have to give what is the input needed to execute the program I have to give. This is what the usual procedure, right? I'm adding a two numbers, A comma B. The answer will be stored in C now. While I'm trying to execute program, or when I'm attempting to do that program in computer, I have to give what is the value of A and what is the value of B. So that is called as the input data. Okay, what I'm giving a program as well as what is input needed to execute the program to my machine. What I can expect from my computer, I will get what is the addition of these two numbers I can get, right? So that is what we are telling it as the output. So this is a normal way we are doing a traditional programming method. Let us come to the machine learning. You see here, I will give the input data. So that is nothing but I will give 2 comma 2. I will give it as the input. Okay. Then I'm giving you a output as well. So I'm telling my machine. I'm telling my own machine. 2 comma 2 is my input. 4 is the output. You see here 2 comma 2 is the input. I am giving the computer output as well. The output is nothing but 4. Now what is the process of computer here? Madam, you have given input and as well as output. Then what is the need of machine? Yeah, here the machine is learning by itself. What is the relevancy between what is the functional dependency between the input data and the outcome? You see here, when I am having a 2 comma 2, there are 4 basic arithmetic operations, or 5 are there, including modulo. If we are taking all 4, I have to do something with that, right? 2 comma 2, I can do addition, subtraction, multiplication, division, or modulo also I can do. On that case, what kind of mathematical concept is behind that part? That has to be learned by the computer. Okay, so what I can get final concept, final output from the computer, it will give you the what is the programming concept between the input and the output part. So you see now you should know, right, what is the difference. Now I'm making the machine to learn by itself. I'm not going to I'm not going to give the entire program to the machine. The machine has to learn by itself. Okay, so but still it is a machine, it can't do anything by itself. I have to give some input to that. I'm giving a input data and the outcome. You see here I have given 2 comma 2, the output is coming as the 4. So 2 comma 2, 4 is there. In 2 comma 2 comma 2 comma 2 is turns to 4 now. Definitely it can't be a subtraction, because 2 minus 2 it will be 0. Division is also 2 divided by 2, it will be 1. Okay, these two operations rolled out. Now I have two more operations, plus 2 plus 2, 4. Yeah, it is correct. Then I will do 2 star 2. So it is also 4. Now machine will get confused whether it is a plus or star. Okay, this kind of thing, how it can be sorted out now. So that's why always telling machine learning, it's just a machine. How much you are training your program, that much you can get a accurate result at the output. Okay, if you are training for only one space, see, you are getting a certain problem. What is that? You don't know. It is a plus or multiplication. Suppose I am giving another one input for the same program. 3 comma 3, I am giving you the 9. So 3 comma 3, 9. So already I have predicted either it can be plus or star. Right? On that case, you see here 3 plus 3, it will be a 6, but my output is 9. So here the machine can understand the previous data is also multiplication relationship, not the plus relationship. Okay, so still some kind of hypothetical values you are giving to the machine. How it can be sorted out by the computer when you are training more number of inputs under the same concept, so that the machine will be trained for a trained with the more accurate level. So that's what we use it to call. Whenever you are doing a training to the machine, how much you are training, that much you can reduce the error in prediction in the machine learning. See, we have to keep remember one thing very clearly. How much we are training it just a machine, there can be a possibility of error in prediction. We can't believe 100% successful prediction from the machine learning. So whatever that's why even you see so many algorithms they are implementing, so many things are going on the current trend, but still there is a hope for the that machine learning projects. Why? Because suppose some person is shown 0.96 percentage of accuracy in prediction, you are doing 0.97 accuracy, it is considered as the best research. So this is the place where it is standing its hope till date. Okay, so how much you are training, that much prediction you get. How much you are reducing the error, that much your machine learning algorithm will work in a better way. Okay, so now we will enter into the definition. Hope I am clear with that difference between machine learning and programming, traditional programming concept. Now we will enter into the definition of machine learning. You see here, there are n number of definitions are there. You can't tell one or two, but here I have given the most apt and most famous definitions for machine learning. You see here, already I told machine learning is science of getting computers to act without explicitly program. Am I given any explicit program to the computer here? No, I have given input data and output data. It is my computer job to find what is the program behind that particular input and output. Okay, it has to find by itself. That's why I'm telling I am making my machine to learn from the input and the output. Okay, that is called as the machine learning. Okay, it is defined by Andrew and G. If you are saying it is available in mid of 19th, sorry, 20th century itself, machine learning concept is there, but it is not that this much advanced in those earlier days. But in 21st century, it is going to its peak actually. That much advanced algorithms are coming. Even I will show you how much easily we are executing the program. Even before 15 years, we don't have this much facilities to execute the things this much easier. So there is another one most probable and most famous and most apt definition for the machine learning. You see here, I have given three things here. Before we are entering into this particular definition, I just want to tell you one practical analogy. Okay, you are driving a car in a road. Okay, you are driving a car in a road. I just want to measure how you are driving, so I just want to tell to someone how you are driving. Okay, so on that case, how I can tell, yeah, she is driving good or he is driving good na? When you are driving in a road by properly maintaining the left side. Suppose some curve is coming, you are balancing in a curve. Even though opposite one vehicle is coming, you know where to balance, where to slow down, and where to increase. If speed brake is coming, how to down the clutch, how you are increasing the speed, decreasing the speed. By calculating everything, I can tell, yeah, she is driving nicely without making any accident, without disturbing others who is driving in the same road. Like that I can tell, right, you are driving good or not. My question is, you are driving for the first day. Will you drive in a proper way, like whatever features I have told it in the last just before 1 minute? The same way you can drive. Definitely, it is not. Once you are driving, first you use it to drive in a certain ground where no one is there. You can drive like anything, so that you are practicing something, right? You are gaining experience to. Suppose you are thinking like you are driving in a road, but you are not actually. First time you are driving, you will not go to the direct NH road and you will drive. No, we use it to go to the ground and we experience ourselves. Then only we will go to the road. Even after entering into the road, also we may face many difficulties, because when opposite one vehicle is coming, you may get fear. You don't know down the clutch or increase the speed, decrease the speed. So this many problems are coming, right? So how you can decrease all those problems when you are doing a more number of practicing, or when you are gaining a more experience in driving, you will be a perfect driver in the road, right? So based on that, you can map the same thing here. I have a certain task T. What is the task of yours? Driving a car, right? I want to improve the performance. What is the performance? To drive a car in a road, NH road, without disturbing other vehicles which is driving in the same platform. And I have to drive in a proper way without making any accident. Okay, so that is nothing but improve my performance. Then how can I improve my performance of the task? By gaining experience. What is the experience? Keep on driving in some ground. After that, you are entering into the NH field, that with the help of someone else. After getting enough experience only, you can drive in a perfect way, right? So the same way, I want to improve the performance of the task T with the enough experience. So now, whatever the machine learning algorithm you are going to implement in your future, you just think for a while how they have implemented. Definitely, there should be a certain task. What is my intention of that particular task? I just want to improve the performance, because why you are doing a task? I just want to increase the performance, right? Okay, how can I improve the performance? Simply I can't do. I need a certain experience. Experience is nothing but practice or training. You can call it anyway. Okay, so this is the most appropriate definition for the machine learning, which is given by the Tom Mitchell. Whatever the actions you are doing, you please keep remember the TPE, task performance will be gained using the experience. Okay, PTE or TPE, you can consider in any way, but don't forget these parts. Okay. You see here, this is a simple overlay of how the machine learning is working on. I have to give the input to the machine, right? So what is my input? Already I told. What is the input data? That is nothing but information, along with what is the prescribed output for the input. Okay, what is the exact output for the input? Both I am sending as the input for the machine learning. You see here, I have given so many things here. I don't know how much you understood, but still I'm telling, there is a certain kind of relationship between X and Y. There may be. Or there may be a certain pattern. So these are all the different ways of finding the relevancy between input and output. Okay. For example, you are adding 2 comma 2, you have to find what is that relationship between the two variables. Suppose you are giving one diamond, one circle, one rectangle, three different things you are giving. You want to find that different shapes involved in the input and output. You have to do the pattern matching, right? Then you have to sometimes you have to find what is the dependency between x and y variable, what kind of dependency is lying on, what is the hidden structure between the input and output. So you may have to apply any one of this technique to find what is the model behind that input and output. Hope I am clear. The previous diagram only I have shown in a different way. I am giving the input as well as output for the same function. Okay. Now what I want to do, I want to find what is the function behind that input and output. Right? Okay. How can I find? It can be a certain relationship or pattern or a dependency or hidden structure. So this is the place where we are using a machine learning algorithms and techniques to find the optimum model. Okay, so this is called as the machine learning simple implementation. Okay, now we shall hope I am clear how the input output is converted into optimum model, right? There are a number of things that we are using. We are going to discuss about one or two algorithms today's class. Don't worry. So the next one is about types of machine learning. Okay, so we have discussed about what is machine learning, and we have discussed about how the machine learning is working. And here it comes what is meant by machine learning models. Okay, what are the different types of this machine learning models? You see here, I have given supervised learning, unsupervised learning, and reinforcement learning. Three things are there. Okay, so semi-supervised there. Semi-supervised is a combination of supervised and unsupervised. So that's why I didn't mention these are the three major parts of machine learning types. So let me come to the supervised learning first. Okay, I told it is a task driven, unsupervised is a data driven. Then reinforcement is to algorithm learns to react to an environment. So before saying this, as usual, I just want to tell you some analogy which will make you to understand in a better way. You see, we are there. Suppose consider our regular class, like our regular class, what we are doing to the students. We are making our students like teaching something. Yeah, this is what the concept of compiler design. For example, you can take LALR algorithm. You are teaching to the student in a step-by-step manner. So this is how LALR algorithm is working. This is the first step. This is the second step. This is the third step. Like that, you are explaining to the student. That is called supervised algorithm. You are telling to the student how what is the input and what is the output coming from the LALR algorithm and what is the steps to be followed. In that way, you are guiding the student in each and every moment. It is called supervised algorithm. Okay, but now I'm giving assignment to the student. See, students, you have to go and find what is the concept behind the LALR. So what he or she can do. She or he don't know anything about LALR algorithm. So she has to explore by herself. Okay, what is LALR? What is the concept behind that? What are the things she is entering into the LALR part without having any basic knowledge? She is exploring by her own self. This is a own purpose, right? That is called unsupervised learning. She don't have anyone to tell this is correct, this is wrong, but she has to explore her by herself, find what is correct, what is wrong. Okay, so what will be the concept involved in that part? Everything is learned by herself. The reinforcement learning is entirely different part. It is according to the environment it will learn. I will tell you, it is the most probable example is online gaming part. Okay, I will tell you when it comes. It is a kind of third algorithm. It will not comes under supervised and unsupervised. It is a separate kind of algorithm. Mostly we are using in all gaming algorithms. Okay, so this is called reinforcement. Hope I have told what is a slight you may understood, but still you can understood very clearly when we are seeing the latest slides. Three types of machine learning algorithms are there. Supervised, this is nothing but someone is there to supervise everything to tell this is the way you have to proceed. Unsupervised, they don't have anyone. They have to explore by their self to find what is the concept. Reinforcement is it will learn according to the environment where it is working for. Okay, these are the three most important types of machine learning models. Let us enter into the supervised learning. You see here, I told already, supervised learning is something like I have a certain set of, before entering into that the definition, we shall see that diagram. So it will be more clear to you. You see, I told in supervised learning, someone will be there. So what is the input is all about? So which means that I have a proper label for each and every input I'm passing to the machine. Okay. You see, yeah, I have a set of fruits in my basket. I want to train my vision. What are the different types of fruits available? Okay, you may have a apple and you may have a orange, plum, like that. Pineapple. So many fruits we are having. What you have to give now? While you are giving a training data set, you have to tell what is the desired output or what is the output over here. You have to find what is this figure is all about. This figure is all about apple, right? Sorry. So this figure is all about apple. So while I am training my machine itself, I'm going to give what is the training data set and I have to give what is the desired output of my input. Both I will give it to my algorithm to learn the thing. So this is called model training. So what is the supervisor here? It means it is not a one man is sitting or one woman is sitting to monitor everything. No, it is a kind of thing. While I'm training my machine, I'm giving you the proper input along with the what is the input is all about. Okay, so it is not mandatory always you have to give a output for your process, right? Sometimes there is a situation machine has to learn without knowing what is the output is all about. It has to predict even training mode itself, right? On that case, supervised is the kind of algorithm where you are giving an input as well as the desired output to the machine to learn by itself. You see here, you by seeing the overall picture, I have trained my machine for a red apple. So as per the picture I'm telling, but you see here I'm giving the input is green apple after getting the trained model, but it is telling correctly, yeah, it is an apple. How it is possible? So that's what I told. How you are training your machine matters here. See, in apple itself you can have a local apple, Kashmir apple, like that. So many apples are there. You see, the Kashmir apple will be big in size, the shape is also somewhat different, right? If you are seeing a local apple, the color is not that much red, small in size, it is not aptly matched with that Kashmir apple. So on that case, what I have to do while I am training a machine for apple, I have to machine the train with the different types of apple. Even green color apple is there. Apple this shape is very rare, and you can see that another kind of apples that is shaping like this, which is big in size and not properly having this kind of bends and all. Also, one apple is there. So like that, I have to train my machine for the apple output in a different various input. Even color may be different, so size is also somewhat can be different from each other. Like that, I have to train my machine. So while I'm training, so pre-processing is one of the intermediate state. You don't worry about this part as of now. I'm going to give it to my computer, so it is giving certain trained model as the output. So you have to keep remember how I have been trained. I'm giving a certain input as well as I'm giving what is the output of this particular image. That is nothing but label of the image also I'm going to give. Okay, so this machine is learning, like if I'm seeing this kind of thing, this is known as apple. You can properly take this example in your home, like day to day life we are using in home with our kids, right? Kids are there in home. How we can make them to learn? You are just one time showing the apple to the kid, you are telling it is apple, but maybe next time it may tell, at may not tell, right? Because only one time you have trained for. So what you use it to do, keep on you telling to the kid, see, this is apple, because you are showing apple as well as orange now. First time while seeing, the kid cannot differentiate, may not differentiate apple or orange. So what you have to do, you have to keep on telling to the kid, see, this is the apple, hey, this is the apple, this is orange, this is orange. Like that, you are keep on telling, it will learn. Whenever after that you are showing the apple, it will tell you, yeah, it is an apple. Right. So in that way, you are making a machine to learn with the proper input along with the desired output. So in that way, I got a trained model. After I'm getting the trained model, whenever I'm giving the input, it can predict the output. Okay, so you see in this particular model, if we are taking a machine learning, but here we are going to discuss only the theoretical part and implementation part. But properly, you want to learn machine learning, you should be master in mathematics. It is most important in data science as well as machine learning. So still, we can't go to that much depth today. I will show you the simple concept behind the machine learning. You see here, already I told I will give the machine certain input along with the certain predicted output. Okay, I told right 2 comma 2, the answer is nothing but 4. So I will give input as well as the corresponding output to the program. What is my process here? I want to find what is the prediction function in my machine learning. So this is a simple example of how I am executing the machine learning process. Okay, this is a simple formula. If you are saying, it will go to the extent, we need not to do that much. See, always when you are doing a machine learning process, you have to do in a two way. One is the training part, another one is the testing part. Okay, what is training part? Now you are going to give red color apple or green color apple or different shapes of apple to the computer, and you are going to tell, yeah, this is apple, this is apple, this is apple. Now it is here, the function is nothing but it is extracting the features from the image. What are the features? How the apple shape should be, what are the color, how that top stem will be using looking like that. It will search the more features from that image. Based on that, it will store its details. So if these features are matching, this is known as apple. So sometimes there can be a mathematical function, or sometimes there can be a set of patterns to be matched for the process. Okay, so like that, I'm training my machine for the n number of input. You see here, a prediction function f by minimizing the prediction error on the training set. When you can do the minimizing error, when you are training for more number of input, the f error will be getting reduced. That's what I told in the previous time. Then next time what we are doing now, just we will give the input to the function f, you will get the output. So in training mode, you are giving input and output, you are predicting what is the error. But in testing mode, what we will do now, we will give input to the function model. It will give you what is the output. So this is that formula involving in the training and testing part of machine learning. Hope I am clear, right? So how you will train X and Y giving output you want it as here. When you are going for the testing part, you are having a function. You have to apply a certain input. You have to predict what is the Y is all about. How you can get extra exert Y when you are training with the more number of X and Y to the machine. You see here, this is the classification example. Classification is, okay, we shall complete that definition. You see, the program is trained on a predefined set of training examples, which then facilitates its ability to reach an accurate conclusion when you given with the new data. So when you are training with the more number of training data, you can find what is that testing data is all about in future. Right, this is called supervised learning. So there are n number of methods available under the supervised learning. They are regression technique, classification, and decision trees. It's just a few I have been highlighted here. Out of this, these two model implementation I'm going to show you in the second session. Not now, we will see in the second session. So this is the thing. If you are seeing to the classification, I told now classification is one of the supervised algorithm. You see here what's happening in that particular part. You see, okay, someone is telling something. What's, madam, please hide Google screen. Hope now it's all right. Okay, we shall continue. Classification example. What I am doing is I have a set of training images. I have plenty of fruits here. That's what I told. Fruit basket I'm having. While I'm training the images, I am giving the label to each and everything. See, this is known as the apple, and this is known as banana. So the image which and all matching this kind of feature, I can tell, yeah, you are belongs to the apple category. Like that, I will train my machine and I will get a certain learned model. You are clear, right? I am giving an image along with the what is that proper output of that particular image, and I am going to train my machine for the function f. I am getting a final functional learned model. This is called me training phase of the machine learning. You see, in the same part, I am going to do the testing. You see now that machine is trained for what are the features of apple, banana, orange, like that. It has been trained. How it has been trained? It has been taken a certain feature, something it has been taken, but we don't know, because it depends upon the image it is getting. Ma, so that what's happening now, it is going to check the feature, extracting the features. Based upon the features, it has been given you the learned model. Now let me move to the testing model. I told, right, machine learning is having two parts. One is the training part, another one testing part. In training part, I have given input. What is the output? The function f is predicted over here. Finally I got learned model f. Okay, in that learned model, what I'm going to do now, I'm going to give the test image for the learned model. So once you are giving the image, immediately the features will be extracted. Okay, so okay, it is looking this color shape. What is the color? Everything will be features are extracted. That extracted features will be matched with the learning model, learned model. Already we have calculated here, right? Learned model we have calculated here. That learned model is going to be combined here. Sorry, compared here. So these are all the features of this current image. But already I have a certain different types of features for each and every fruit. I have been trained already, right? And that is what I am doing. That particular part is searching. So after that, it is telling like the maximum feature is mapped with which particular fruit that will be predicted as the output. You see here they are giving it as a prediction, because already I told, even it is just a predicting something, it may be, but still it is not telling 100% this is belongs to apple only. There is no such assurance is available. Okay, so simply it is mapping and it predicting it may be apple, right? The next one, you are giving a certain image. It is an orange actually, right? It is extracting a features. It is learned with the model, but it is predicting it is a plum. Definitely, it is not a plum. So what happened? Your prediction is wrong in this place. So what you have to do? You have to again keep on learning this machine for the orange images more and more. Okay, so kids are telling, right? If they are trained for certain image, next time you are showing it, they will confuse the things. Maybe because of the features or something else, they are getting confused. So what you have to do? Again, you are keep on telling them, see, this is orange, this is not a plum, like that. So the same way you have to train your machine for more number of oranges again, so that you will not get any doubt later. You see here, I have given a cherry over here. It is extracting the features. It is mapping with the learned model. So it is predicting in a right way. Yeah, it is a cherry. So why I have shown this as wrong? Na? Because in testing, it is not mandatory. Always it should be a right way of prediction. Since it is a machine, you can expect for some kind of corrections in that. There is a possibility. Okay. So next one, this is a real-time example, house predicting houses. See, here we have shown two different algorithms, right? One is the regression, another one is the classification, right? So if you take a regression part, it is for a continuous data. What is continuous data? Suppose your belongs to a certain area. For example, you can take it as the Chennai. Okay, in Chennai, OMR area, I am the new to Chennai. I want to get to one house over in that particular place in my budget or based upon my need. For example, I want a three-bedroom flat. I want to know how much it may cost. I don't know anything about OMR since I'm new to area. I want to see something like how it can be. So what you can do now, you can have a certain machine learning model. So what is that all about? You are going to a certain, you are taking a certain model. OMR area, you can go and collect the real-time data. Suppose the house is for three-bedroom, it is having a certain size. What is the rent? Okay, like that you are going to collect the data from that particular area. Three bedrooms are there. Altogether, it is coming under 1,000 square feet. And that case, what is the rent? If it is a 400 square feet, one bedroom flat, what is the rent? Like that, you have to collect all the details. So you are having a house size and you are having the price. You are going to draw one graph. Okay, 1,000 square meter house. How much it is? 1,500. Sorry, 5,000 rupees. Then sorry, some rate you can fix randomly. Okay, 4,000 square feet rate, it may be a 20,000 rent, and 4,500 square feet, it may be taking a 25,000 rent. Like that, what is the real data? You have to collect the data and you are drawing one graph. You are finding the graph between that. Okay, so if you are collecting such kind of data, definitely the data will be continuous in nature. Why? Because you are going to find a 400 meter, sorry, 400 square meter and 500 square meter, 600 square meter, like that you may get a continuous set of values in that particular area, and as well as you can get the output as well. What is the output? This much square value is having this much rent. Okay, you're having two values. What is the square meter? What is the rent of the house? Two things you know clearly. So what you are doing, you are finding the functional dependency between, or you are finding the dependency between the these two values. Okay, so simply if you are saying y is equal to mx plus c, that linear model you learned, right? That model, if you're applying here, it will be working very clearly. So always what you have to do, you have to draw a central line between the entire graph. So in that part, what I'm doing is I'm just drawing a particular line between how this line will come now. If that initial maybe the line will be like this, but when you are training, you are programmed with n number of inputs. Your y is equal to mx plus value will become more or less in the middle value. So if I what I'm telling, this is already trained. The person already paying their rent. The person already leave the home for rent. As per that particular data, I have drawn a graph for the house size along with the price. What is the square meter? What is the corresponding price of the house? It may be more or less. Sometimes the house size is very less, but they are charging more because of the facilities available. If you are taking only one feature, there may be a disadvantage. If you are going to the gated community, one bedroom flat itself five. But if you are going to the normal apartment, one bedroom flat will be less in rate. It's because of the amenities you are having in that particular area. But here I have taken only one factor, that is nothing but house size only. As per the house size, I am fixing what is the price of my home. Right. And that case, what is happening? If I am taking a two parameter, house size and amenities available, for example, parking, water, park, that kind of things, while I'm adding this graph may get varied. That is called multiple linear regression. So you are concentrating more number of things. But this is a simple linear expression. I'm not going to concentrate with the more things. I'm going to take only two features. I want to find what is the relationship between each other. On that case, I can draw after putting enough number of train data in that graph. I'm going to draw one central line. This is known as the normalized line. What will happen in later on days? Suppose I want to get a certain house with the size of 3000 square meter. Okay, so what I can 1000, 2000, 3000. I will go to 3000. Let me consider it is a 5000, 10,000. You see, my 3000 square feet home will approximately cost 22,000 to 25,000. Like that, I can tell. You're getting my point. So I am new to OMR. I don't know anything, but by seeing the graph, I may come to certain conclusion. If I want to take 3,000 square meter one house for the rent, it may cost up to 20 to 25,000. So it is up to 20 to 30,000, but still it is going to the meet the middle level. It doesn't mean that it exactly you can get for 25,000. No, it is not at all. See, sometimes already I told it is a prediction, so I can get some idea. 20 to 30,000 I can get some house in a OMR area. So definitely it will not come to the least level I can get for 5,000 rate. Definitely you can't get for the 5,000. At the meantime it will not go to above 40,000 also. So there is a prediction like 20 to 30k I can get one nice home for the range of 3,000 square meter in the OMR road. So this I can predict using that regression model. So when you are having the continuous set of data, you can find what is the dependency between the data, and later on you can predict how the things are happening in that part. Okay, so this is called regression. Hope Boston house prediction program you heard. This is a very famous algorithm in that linear regression part. So that is called predicting house prices. The same thing I will show you in the implementation in the second session. Okay, so this is called the regression model. So where I can apply this, when I have a continuous set of data, I can apply this model and I can find what is the relevancy. Based upon that, later on days I can predict approximately what can be my final output. Still I am telling it is a prediction or the exact value. Why? Because see, but still I may get some figure 20 to 30. It will not go too low and it will not too up, so I can get some figure, right? So that is what called as the prediction thing. See, there is not necessary always it should be a continuous value. You see here, I have a different types of flowers. So this is that iris. Hope you people heard about iris data set. If you have heard about the machine learning already, this data set Boston and iris are the two famous and most important thing they are used to keep on telling in that machine learning training part. So this is the example of classification. What does mean by classification? No? I know, see some, for example, you can take this as a classification algorithm. It is not the continuous data. What is mean by continuous data? It is X this value, Y this value, like that. The values keep on going to increase or decrease over there. Here, classification technique, I don't have any continuous value data. It is a categorical data. I can categorize each and every fruit separately, right? So that kind of categorical data will be applied in the classification model. Okay, hope now you are clear with what is regression, what is classification. Regression is something like population growth or COVID cases. You can take it as the example. Per day, this much is increasing, increasing, increasing. That flow also you can take for the regression model. But here I don't have that kind of continuous data. Instead of continuous data, I'm getting a categorical data. Category wise, I have to divide the data set. That is called classification technique. Iris is a certain kind of flower variety. In that iris flower variety, based upon the flower type, I can divide the iris into three types. Okay, there are certain features are there, that is nothing but petal width and petal length, sepal width and sepal length. Based on four features, I can differentiate the iris flower. Okay, so based upon the features, I can divide the flowers into three types. What are they? Setosa, vesicular, and virginica. So these are the three types of iris flowers. How I am doing this particular part? I am simply doing a classification. If suppose the petal width and petal length is from 2.5 to 5.5. So if this is the length and width, it is matching. That maybe belongs to Setosa. If that length is from 5 to 7, then I can tell it is a versicular. 7 to 9, it is going now, it maybe belongs to the virginica. Like that, I am going to divide the data as per its category. This is called as the classification technique. Okay, so I don't have any continuous data here. I have a range of value. That range of value, which and all meeting, that is belongs to a particular category or particular classification part. Okay, so this is called as the classification technique. Even this also we are going to see the implementation in the later session. Okay, so the next one is all about supervised learning. Okay, you see here what is mean by supervised learning. Hope I am clear with the unsupervised learning. What we have discussed in the unsupervised learning, I have to train the data, right? In that training part, I will give what is the desired output is all about. I am processing the input. Finally, I am getting a certain trained model. After that, whenever I am asking, my machine is able to give the answer to me. But how it is giving, keep on training only, it will give the correct prediction. Okay, what is the mathematical concept behind that? What is the training part and what is the testing part is all about? Okay, in that we have seen two different examples. One is the regression for the continuous data, another one is for the discrete or categorical data. This is known as the classification model. Okay, so these are all the two different algorithms that involved in the supervised learning. Let me introduce about the unsupervised learning. Right? Already I told what is meant by unsupervised learning. So the unsupervised learning is something like already see this can I can give you one analogy. You are watching a football match. Just consider you are watching a football match for the first time. You are entering into the ground and you are sitting at one place. You are watching the game. So you don't know what is meant by goal, goalkeeper, nothing you don't know. You are simply going and sitting and you don't know how many people use it to play. What is the thing? Nothing you don't know. You are sitting in a ground. Now, only thing I can predict in that particular ground, so two different colors of uniforms are there, so which means that two different teams are playing. Well, I can count that, suppose blue color, let me count how many blue heads are there, 11, 11 are there. Na? Okay, 11 people are playing in one team, another 11 people are playing in another team. Example, I am telling. So I can come to a certain conclusion. Football is a kind of game where two different teams can play in a single ground at the same time. This many people belongs to that group and this many people belongs to this group. One is defending at the in front of goal. So they may be known as the goalkeeper. See, I don't have any knowledge in the football ground, but I am going to the ground. I am exploring by myself to learn based upon the what is the concept, what is the relevancy, how I am going to match with the things. Like that, I am learning by myself. This is called as the unsupervised learning. You are getting my point, right? I don't have any supervised over there. I just want to learn by myself how the things are happening because there is no one to guide me there. I don't have any supervisor over there. Similarly, so this is called unsupervised learning. Now I will show you this in a the same analogy you can apply over here. It will be understand. It will be clearly understandable to you. You see here, I am giving you apple, banana, say something mangoes. So many fruits you are going to give. You see here only the interpretation I am going to do because I don't have someone here to tell, see, this is banana, See, this is Apple. I don't have anyone to tell. So what it is doing now, it is finding the interpretation or matching between itself. I'm going to train with the 100 images maybe. In this all 100 images, it will check by itself who and all matching. That will be put it in a single category. I don't have something called APPLE, Apple, BA, and I don't have that kind of things as the output here. Instead of that, I am going to get output as the different data, what it has been learned from. So these groups of Apple will be combined and put it in a one box. Okay, you see here, group of apples are there. It will train it itself with all 100 images who and all having the common feature that will be given as the one output. Similarly, I'm having it 25 bananas with a different shape. One is small, one is length, like that many bananas there, but still based upon the features, shape, color of that peel, based on that everything, sorry, color of the skin, based on everything, it is going to be categorized as the another one part. It is nothing but a banana, but it don't know its name is banana. It's no, I have a certain image in my part that is known as yellow color. It's like same uniform. One is in blue, another one is in yellow. I don't know blue is belongs to one country, yellow is belongs to what country I don't know. But they are belongs to two teams I know. I don't know what's their name, right? How can I know by seeing simply blue is belongs to this country, yellow is belongs to this country? I don't know, na. So like that, it is just categorizing all blue uniform in one category, yellow uniform in another category. Like that, it is categorizing its input according to its learning own interpretation. Okay, so this it will do a certain kind of algorithm to do something to get a model trained with. Hope I am clear here. I'm not giving any input or out. Sorry, no, I'm not going to give any label or output part to my machine. So this is the place I told it is not mandatory. Always I can give label to my input. Certain place machine has to explore by itself to find what it is all about. Okay, this is called unsupervised learning. Hope you can find the difference over here. You see, when I'm doing here, I have given one supervisor here and I have given the desired output as well. That's why I'm getting it is an apple I'm getting as the output, right? In supervised learning. But you come to the unsupervised learning, I don't have any supervisor and I don't have what is the label for the input. So what I'm getting as the output, I am getting this is a apple. That symbol only I'm getting. I'm not getting the final wordings kind of thing. It's just it matching with the pattern and it is telling this pattern is belongs to this image. Like that I will get. Okay, you see here, unsupervised machine learning is typically tasked with the finding relationship within a data. Just you are finding that color of t-shirt or shape of the fruits, like that I'm doing something, right? There are no training examples used in this process. Instead, the system is given a set of data and tasked with finding patterns and correlations therein. You're getting my point. I have given a bulk input raw data. It has to find the interpretation and it has to find the what is the correlation between and pattern between them. Okay. So this is the many methods are available. The one is the clustering method. Another one is neural network. So most of the neural network algorithms are based upon unsupervised learning only. It has to explore by itself to find the patterns among them. Okay, so that is that if you're entering into this is a very depth part, we can't touch that. So this is the way it is going to explore with the unsupervised learning. Okay, you see, you can take an example. You are seeing online news forum and all, right? Suppose you want to read a certain sports news, you are searching in a online news. See what's happening in that clustering part. Clustering is one of the unsupervised learning method where it will just cluster the things based upon its relevancy. For example, you want to find the sports news. The sports news came in BBC or it came in Indian Express and Hindu news, like that. Many things are there, many online news channels, online newspapers, something same. So many things are there. I just want to find what is that sports news of today. Okay, if I'm googling it, what is happening? Immediately, it is showing all the sports related data in my browser. Right? How it is happening? First, it will going and finding the cluster. How the cluster is happening based upon a certain similarity. What is the similarity factor I have taken over here? It is tagged as the sports. Even it can be a running, or it can be a football, cricket, volleyball. It can be anything, any athletic event or any team event. It can be anything. But all these things comes under a single category called sports. So what is the clustering factor I have been taken over here? It is something called related to sports. Okay. For example, if I want to read something like science and technology, okay, the science and technology, it can be a COVID medicine is finding in already Russia. Now that UK is also going to file another one patent. India is also doing testing a three more medicine for COVID. So if I want to find a science and technology, all the related informations related to that science and technology will be grouped under a single gate, and it is projected to the user. How this is happening? If you are seeing background of this particular thing, it is a clustering of the thing. What is meant by clustering? It will take a common features. Based upon the features, it will group the data into a single gate. Okay, so this is called, I don't know anything about news. I'm simply entering. I'm finding what is the relevancy between these two words. This is nothing but sports is the common thing. So I'm going to make it as one gang. Another one. So I'm seeing one is the Russian news, another one is UK, another one is about Japan, China, like that. I'm getting something. So I consider this is the world news. So I have to consider it as a single group. So like that, entertainment. So like that, I can group the news according to its nature of data, what kind of things it is projecting to the user. So based on that I'm doing. So this is called as the clustering technique. It is nothing but document retrieval process. Hope you heard about this part, right? So how this document retrieval is doing now, you don't have any prerequisite, you don't have someone to learn. See, if this news is like this is known as sports news. No one will be there. Simply it has to explore by itself and find this is sports news. Okay, so this is the one of the most famous and most important example for the unsupervised learning. Okay, so the next one is about reinforcement learning. Okay, I told already this is the third method. I will tell you when it comes. Okay, here before entering into that part, I want to go with an analogy. You see, here I have given you an analogy. I have a certain dog. I bought one dog from shop. Okay, this is the first time I'm getting that dog in my home. I just want to train my dog. Okay, how can I train my dog? First time I'm giving a food. I'm seeing what is the reaction of my dog. You see here, it is getting salivation, because whenever it is seeing the food, it get tempted, right? So you are getting a certain simulation from the dog reaction. You see, when next time you are just giving a ringing a bell, you are ringing a bell, but dog is not at all giving any reaction. It's simply sitting in home. See, it's not giving any reaction. What kind of reaction you can expect from dog when you are belling, right? Nothing will happen. So it is like a neutral. It is simply giving with a negative response. No salivation, nothing. It was simply sitting. Next time, what you are doing, you are giving a food to the dog. Meanwhile, you are ringing the bell. You are getting my point. First time you are giving food, it is getting salivation. Next time you are trying to feed the dog using a bell, but you are ringing the bell. It is not at all reacting. You don't have food at that time. Only bell you are ringing. It not at all reacting. Third time, you are ringing the bell. Meanwhile, you are showing the food to the dog. So it getting salivation. The salivation is getting because of the food, not because of bell. But still, the dog is seeing that bell ring as well as the food. You are keep on doing this for continuous 2 days. The after 2 days, if you are seeing, when you are ringing the bell, you will get reaction from the dog that it getting salivation, right? How it is possible? So the dog gets to know whenever the bell is ringing, the owner is going to give food to dog, right? It knows that anyway. When the bell is ringing, it knows that yeah, I'm going to get a food. So defaultly, it is getting salivation. So how this happening? You are making your dog to learn according to the environment. You are training your dog, right? You are training your pet. So how it is happening? You are seeing what is the reaction at the each and different levels. At different level, you are monitoring what is it reaction. So whenever you are getting a certain reaction, that will be recorded as the reward. What is the reward? Oh, okay, this is the point. The dog is getting simulated, and you are getting a certain thing, but it is you are not getting any reaction. So you will be monitored. This is called as the negative response. So it will be considered as the punishment. Next time, reaction, reaction. So based upon the exploring with the multiple factors, I'm just learning which one will make me to go to the success level. My default success level is whenever I'm ringing the bell, my dog has to come and eat the food. This is my task. How I'm doing that by exploring with the different part, I'm getting the certain output. So this is called the reinforcement learning is the agent based upon the environment. It is going to learn the things based upon the environment. It is going to learn the things. You see here, you have probably have played all the online games, that too in the COVID time lockdown period. We don't have anyone to play. What we will do, we use it to play ourselves chess or something in a against the machine, right? You are making a move against you, the machine also making a perfect move. If you are not playing in a good way, the machine will win you, right? Your machine maybe won the game. Hope many of you have experienced in this lockdown period. So how it is happening now, that kind of things, it knows if user is moving this coin, what can be the probability of getting success in the next move. So whenever each and every move has to be done by the machine, the success of the machine will be calculated and then only it will be moved. So how the machine is calculating now? It has been trained for lakhs and lakhs of time against the environment. If I'm moving, the only few coins are there, right? If I'm moving this particular soldier to two step, what can be the reaction? If I'm doing this, what will be the reaction? What will be the reaction? Like that, each and everything will be recorded as the reward. What is meant by reward? You are getting success with the environment. Okay, so this is called as the reinforcement learning. You see here, what I will do in that particular point, I will give the input data apple or not, I will give. Okay, I will keep on see, the thing is, I'm going to give, I want to know it is an apple or not. This is my raw input. And that case, I will give it to the environment. It will check. First, it will go and check really it is apple. Yes, na? Yeah, it is yes. No, na? No, it is something wrong. So I have to consider it as that it is not at all correct. So you should not add it in the reward point. Whenever you are adding a reward state, the agent knows that he is the successor. Whenever you are getting a reward is zero, which means that whatever you have predicted in the step is wrong part. Okay, so based upon that, it will store the data with itself to find the trained model. Okay, so whenever I am getting a yes in that particular part, that features only counted in the trained model. The remaining features and all will not be counted because I didn't get the reward value as 1. Whenever I am getting reward is equal to 1, I know that the model is trained in a successful way. Okay, that features only calculator. So whenever I am giving you that particular green apple or something, it will tell, yeah, it is an apple because it has been trained for it, right, according to the environment. But instead of this example, you can take the best example is online chess game. You are moving something, but you have lost the game. Then you have to do a next move and you have to see what is the reward. If you have won the game, that will be recorded with the IG agent. If you lose the game, that will not be recorded with the model trained. So that's why if you are not playing in a better way, you will get lose with the machine which you are playing in the opposite side. Okay, hope I am clear with that reinforcement learning. So this is nothing like you are taking actions in an environment. So maximum notion of long-term reward, which one is getting a long-term successive reward, that will be taken as the successful state. Okay, reinforcement learning algorithms attempt to find a policy that maps state of the world to the actions that the agent probably to take those states of success. That only will be counted to find and react for the further cases. Okay, there are n number of things available: criterion of optimality, brute force, Monte Carlo methods. Some of them are used in that gaming development. Okay, so if you take the reinforcement learning, maximum it will be used in the game development mode. Okay, so this is called reinforcement learning method. Okay, so totally three different methods we have discussed today. One is about supervised learning. That is nothing but you are having on supervisor to tell what is it all about. Okay, unsupervised learning, you don't have any field knowledge. You are simply getting a raw data. You have to find the pattern behind the different inputs and you are telling what is the output. Reinforcement learning is the one which is learning based upon the environment. That based on that, it is going to predict what will be the correct one. Okay, so the next one, so this is the overall. So initially, I have shown something which is not core technical part, but see, this is a technical way how the thing is executing. You are giving a certain kind of data, you are applying a certain idea behind that, you are developing a certain model for the given output and the idea. Okay, then what we have to do once you are getting a model, you have to train the model like anything. See, always it is a 80-20 rule. Hope you may be heard about it. Suppose you are having 100 input data you are having for the training purpose. What you have to do, you have to divide your data into 80 is to 20 percentage. So out of 100, 80 inputs are allocated for the training. So the remaining 20 are allocated for the testing purpose. So what is the testing purpose now? I have trained 80 images already. That another 20 image, I know what is the probability of output, I know. Because that is also input as well as output given by me, right? But I am testing against the training model. Really it is working fine or not. I am comparing the result. Yeah, my model is working fine. No, something is error. So I have to change something in training model. Again, I have to execute. Like that, I will do by myself with the testing part. After that only, I will go for the live execution. So this is what happening with all the machine learning algorithms, what we are implementing in our real time actually. Okay, so if you are giving a raw data, that raw data will be pre-processed. What is mean by pre-processing? Some missing values may be there, some outlier values may be there, and the data are not in a proper order. That everything will be doing in a pre-processing model. So the model which is taking care like what are all the things need to be corrected before I'm entering into the process. What are the things to be corrected that will be done in a pre-processing model, then you are getting a final prepared data. See, data science you may be given na, if you are taking a certain database, data science, suppose you have executed already, you must be aware of it. If you are taking a certain Excel sheet of 1,000 data example, it is not mandatory all 1,000 into 10 columns should be filled. Some may be still empty. I can't leave that empty space to do a calculation, right? So I have to fill the data by somehow. How can I fill? There are certain models behind the pre-processing technique. Then data cleaning should be done, and some data will be out of range that I have to correct it. So many things involved in the data preparation. Once you have completed the data preparation, you have to apply a certain machine learning model to get a candidate model. Then you have to apply a chosen model which will be give you a final candidate model which can be applied for the different applications. Okay, so this is how a particular machine learning model is going to be developed with the every process what you are doing seeing in nowadays. Okay, then machine learning applications, if you are seeing machine learning applications, there are n number of applications you are seeing in day to day life actually. It is not something like we are not at all using. It is we are using in a day to day life. You can take it as the Google review. Hope everyone are aware of Google review. I want to know if a certain product is a really good or not. Sometimes what's happening with e-commerce website now, they are not at all giving a right feedback. For example, even Flipkart also you are saying sometimes a product has been bought by 1,55,000 people, but the same product if you are seeing Amazon, they use it to show only a 45,000 people only, but we don't know which one we have to believe, right? But still, whatever it may be, if you are going to the Google review, it can tell you this what are the features of a product. So what are the feedback of the product based upon the features it has been considered, what are the things it has to be what are the pros and cons of the product, everything will be listed out over there. How it is doing, it is called as the sentimental analysis. This is also one of the most famous research field that most of them are concentrating on nowadays. What it will do now, it will take input from various parts, various places, social networks or e-commerce platform, wherever it may be. It will take all the inputs and it will be given as the input to the model, right? When I'm doing this kind of thing, I have a certain output. What is the output is only two here. You can have it as the three also: positive, negative, neutral, because one something is there, right? It is not too good, it is not too bad, okay kind of product. So that is comes in a neutral part. So this and all fixed by us only. Okay, so in that part, what will be happening? It is taking input from the multiple websites and it is exploring by itself. Like I'm getting this much big sentence. What I will do, I will divide each word, divide the sentence into different words. Then I will find the probability. Then based on the, I have shown only one hidden layer here, but it is not only one hidden layer. It may have a n number of hidden layers between input and output. So what it will do? When I love, great, thank, that kind of things are coming in my input, tweet or data I got from various platforms, I'm getting this kind of words, which means that the word is giving a certain positive response. Okay, the product is okay, not too bad. Like that kind of words I'm getting, I can come to a conclusion. This is a kind of neutral kind of product. Then I hate. It is a pathetic. I'm sorry for that. Sorry for the purchase, and I'm really feeling bad for the purchase. Like that, I'm getting some words. I am getting in that flow, which means that it is completely negative. Okay, I am not at all satisfied, not satisfied. Only satisfied you take, it will be coming in a positive. But so what you have to do, you are dividing into a single word. That single word will be again combined into various combinations. Right, you are getting my point. First, each word will be separated. After that, you are seeing that multiple combinations of words will be calculated. Based on that, I will predict what is the final output. So this is called sentimental analysis. So based upon the different reviews, finally I am coming to only two conclusions. The product is positive. No, it is a negative. That's it. Okay. But if you want to have, you can have one more layer here. That is nothing but neutral. Okay, so like that you can add the things over here. So this is called sentimental analysis. Then product recommendation. You see, you are buying a certain mobile in an online platform, right? If you are buying a mobile, when you are about to move to the cart, it will tell you, so the customer who bought this particular product also purchased these items. Like that, they are recommending something, right? How it is possible? It is also a kind of machine learning. How it is learning? Na? The machine is keep on tracking about previous history of the persons who and all purchase the mobile. Okay, whenever you are purchasing a mobile, by default, the person will buy back pouch and the screen card, right? So that suppose before that the product is bought by 80,000 people. Out of 80,000 people, nearly 40,000 people have ordered back pouch and what we call scratch card together. Whenever the next person is going to order that mobile, by default the machine will recognize that it is also the what you need it. You can add or you can skip the product, but it's our choice to buy. But the still the e-commerce website is giving you a recommendation. If you want to purchase, please add it. It is giving no. This is called as a product recommendation. How it is possible? It's keep on tracking that website who has purchased that mobile, when they are purchasing what and all the products in their cart. It is checking because it is and all the related cards now. Okay, so who those who are buying mobile, they will buy screen card and back cover, so that it is recommending for the others. Okay, suppose you have purchased some kind of kids product before 6 months. Okay, after 2 3 months, if you are opening the Flipkart, it will show you. See, before some time you have bought this product, you maybe again need this particular product, or something you bought in a baby care. It will show you the related things in the baby care in the further order. Suppose you have searched for the toys, it will show you next time. See, this new toys is available in Flipkart. Do you want to purchase? How these things happening now? You see, they have shown here. They are seeing what are the products purchased by the customer in a continuous way. Based on that, okay, they have purchased certain baby care, they may need the baby care in near future, so it keep on recommending you. Okay, this is also learning from your past purchase. Okay, from your last purchase, it is reading something, it is recommending you one type. From the past purchase of all the customers in the e-commerce website, and it is recommending you is the another type. But you see the common feature behind that is by reading everything and recommending the things. Okay, that is the overall feature. You see here, sometimes you may be viewed but you didn't purchase, right? That we use it to search n number of things in website, but we don't buy that things. Also, it is only because of the search history or log detail of your e-commerce website, and then it is giving a default reminder to you. You want to purchase, some offers are going on, everything happening because of the machine learning. Then learn approval is also a kind of thing. It will search. If you are giving information, it will search in a n number of way. You are having a criminal record, you are having a this much percentage of salary, and how what is the year of experience in your job, you're having a credit card, you're paying it in a right way or not. All these features will be considered in a path. What is the thing? By default, the machine will tell the particular person is eligible for the loan or not. This is also a kind of machine learning algorithm. You see, there are n number of things I have listed out here. Online chatbot and all you are doing, right? If you are entering into the website, immediately it welcome you to the, for example, Coursera course, what you want to learn, like that. It is giving you a certain online chatbot. That is the kind of machine learning which has been trained for a certain kind of prerequisite question. If you are asking something related to it, it will answer. But if you are posting excessive question, it will tell like, you are my our customer care people will contact you very soon, thank you for contacting that so and so, like that it is telling something, right? This and all, yeah, part of machine learning examples. Okay, Google Translate. If Google Translate and all you are doing now, it is a machine learning application, but it is using a neural network concept. It is not a simple machine learning. It is taking a neural network concept, because translation is not simple word. You want to translate one word, one language to another language, you have to do a more kind of predictions, because you want to give the proper output to the user, right? So that it is using a neural network concept. Most of these things are involved with the neural network concept, because it will find the more accurate result when you are comparing with the all other things. That's right. Okay. So these are all about the introduction to machine learning. We have still, if we are discussing about application, we need one separate session for applications alone. That much are there, but still I have given you just to overview. Okay. Now we shall see about that. Just intro I will give. The remaining thing we will discuss in the next session. There are n number of things available to implement that machine learning, but one of the most trending and most easiest way to execute machine learning nowadays is Python language. Hope everyone are hearing about this word. In this lockdown period, you may also attended so many workshops and FDPs in terms of Python in data science, Python in machine learning, Python in deep learning, like that you have seen. So that much, why this much famous this Python language? So if we are definitely we are studying for past 10 years or 15 years, definitely. So in this past 10 and 15 years, we are not hearing this Python language this much trending. But very recently, if you are telling almost 5 to 6 years or 7 years, in that last one decade we can take. In that decade, why the Python is getting this much familiar and this much trending in industry, even in academics, everything, it's because of its powerful library what it is having actually. If you people have worked with MATLAB and all, how much struggling to do a simple program, it is really tough to work with when comparing with the Python. Okay, whatever you want to do, simple thing, you want to import library, that's it. After that, whatever you want to do, you can simply do. For example, you want to do a matrix inversion. See, you just consider, and you don't go with the scientific part, you just consider in that mathematical concept, sorry, C programming. If I want to do a matrix inversion in C programming, minimum one page code I have to write, right? But see, in Python I have to do only 3 lines of code, that's it. First line I want to import that numpy, the second line I want to take one matrix, third one I can inverse it, that's it. 3 lines I can complete the entire matrix inversion. So that much powerful library it is. It is a open source, that is another most important. You need not to pay, you need not to download some unauthorized software from that website, sorry, what we call from internet and all. Even open source legal software you can download. It is very powerful, flexible. It's all because of how much data you are giving. Already I told, if you are doing int a comma b, there is a restriction to give value for a and b in C. But if you are simply adding C is equal to a plus b in Python, there is no restriction to give what is the size of the data. There is no long double, nothing. Simply it will take, right? That big data availability, versatility of that programming language, cost of ownership is zero. So based upon all those things, the Python is getting trend in the current race. Okay, then we will come to the machine learning perspective. I told already Python is very famous because of the powerful library, but here I want to show you what are the powerful libraries. Escape learn. Wherever you have see the Python program, even if you're aware of the technique or not, you have simply you're opening on Google page, it is showing import sklearn. That is known as scientific kit. That is known as scikit-learn. This is the one most important machine learning library which will contains most of the machine learning algorithms. All the things is included here. Linear regression, I told, right? Then Kane and algorithm and classification, different models are there. Everything is bundled under the scikit-learn library, machine learning library. Okay, NumPy is the numerical pi, pandas, matplotlib, NLK, TK, NLTK. These are the different Python libraries. I will give you a small introduction about all these libraries. What are the mandatory things we are going to use? Okay, so NumPy is the numerical Python. I told right already. We can find the inverse of matrix in a 3 lines of code. That how you can find is using a NumPy only. Okay, that numerical Python, it can handle a huge number of two-dimensional array, and matrix processing can be done using a numerical array. You see, in this particular Python library, sometimes it will work on top of one another. It is not a self in the solo packages. It will run on one another. You see here, foundation of NumPy, if you are designed SciPy, I don't know you heard or not. SciPy is nothing but scientific Python. It is entirely for image manipulation and creating a graph, that kind of thing. We use it to use SciPy. The NumPy is the basic for most of the things. If you are taking NumPy, it is imported in SciPy, sklearn, and most of the things it is integrated part NumPy. It is always binded like a top of one another. Like that, it has been created. You take the sklearn, that is scikit-learn. It is one of the most popular machine learning library for, I told already, it is included for all ML algorithms. What ML algorithm? Supervised, unsupervised learning, anything can be done to that. You see, in sklearn, I am going to use now. It has been designed on top of NumPy and SciPy. So these two things are the sklearn. If I want to use, I want some places NumPy and SciPy also. So it has been designed on top of these two technologies. That's why I told already these Python libraries are interconnected with each other. Matplot library, hope you heard about this. This is purely a data visualization part. That is nothing but you want to do a certain plotting kind of thing that you can done using a Matplot library. Okay, then pandas, if you are taking now, you are having a data, right? For that pool of Excel sheet you are having now, that pool of Excel sheet, you want to do a certain kind of extraction, preparation of data, you want to do a summation, you want to do a minimum, you want to find minimum value, maximum value, aggregate function. So many things you can done simply by importing a pandas. Okay, that too, if you are going with the data science, without pandas, nothing you can build. You can do all the kind of magics in the data. Okay, that is called pandas. TensorFlow and Keras are the part of Google. If you are seeing what we call Google Colab, if you people are using the TensorFlow and Keras, they are having an option to learn in that particular platform itself, because this has been developed by the Google. Okay, what is the use of these two things? No, actually, they are dependent on each other. It is working. Keras are working on top of TensorFlows. Okay, what is the process of what is the usage of these two things? It is purely a neural network based implementation. Okay, even if you want to do a simple neural network process, you can do using a Keras in a simple way. Even TensorFlow and Keras are binded each other. You can do all the kind of wonders based upon neural network using these two library packages. Okay, so then what are the open source tools are available now? Offline tool, hope you heard about Anaconda. It is a bundle which is includes the Jupyter, Spider, Orange 3, R tool, like that. So many things are bundled in Anaconda, which is offline tool, but it is a open source. Once you have installed in your system, it will be there for long while. You need not to, once you have installed Anaconda, you need not to install like separate Python, R and all separately. It will comes as a bundle. Okay, if Spider, it is a static way of Windows based execution. Jupyter you are using, it is a web based execution. Hope you people are clear with the Jupyter notebook and all. So this is the offline resource for the entire execution. Okay, the online resource, hope because of this COVID, many people previously you are not available also. Currently you are available with Google Colab. It is an online Jupyter notebook provided by the Google. Okay, collaborator, Google Collaborator it is. It's like G Drive. When you are creating one Gmail account, by default, you're getting one G Drive bundled with that Gmail account, right? Similarly, if you're having a Gmail account, definitely you have one default account in it. Okay, when your system is low in capacity, like 1 GB RAM, 2 GB RAM, you're having, but you want to execute a neural network in your process, definitely your machine will not support, right? On that case, what we have to do, so we have to seek for upgradation of the machine. It is not at all possible, right? On that case, you can use the Google Colab, which is giving 8 GB RAM to 12 GB RAM based upon your need of the process execution. Okay, it will do by itself. You need not to do anything explicitly. Kaggle is the one of the online tool which is giving a platform to learn, and it is also giving a platform to execute in real time, like Google Colab. Now today I'm going to show you that. Uh, uh, Going to show you that the demo in Google Colab and Kaggle, both the thing I want to show you, that we will discuss in the next session actually. So that's all about the open source tool that we are having for the ML implementation. Still a lot more are there, but these three are the very high and very familiar and very convenient tool to execute the machine learning. Okay, so hope we have completed about introduction to machine learning. Just we have started with what is it all about, and we have come up with the what are the different machine learning models. We have seen the examples, and we have seen the various applications of machine learning, and it has been ended up with what is the famous language, why it is famous, and what are the tools for implementing the machine learning. So it is over now. If you have any queries, you can ask now. Yes, you can go for a break and come back for the implementation session on machine learning.
Participants, if you're having any queries, you can post it in your chat box.
Hello, ma'am.
Yeah, ma'am.
Kaggle is offline or online, ma'am?
Kaggle is online, ma'am. Online, ma'am. You can check.
Online.
I will show you, ma'am. In next session, while we are starting itself, I will show you how to open,
We
how
can
to do
use
it.
it in
I
a
will show.
smartphone, ma'am. We can use it in a smartphone like that.
Ma'am, while you are using in smartphone, you will not get that much comfort zone. If you are working with that laptop version, yeah, it is available in smartphone also, but you can't expect that much nice interaction. As of my knowledge, it won't get that much convenient to work on, but it is having a desktop mobile version as well. It is there now.
Okay, okay, ma'am. Okay.
Okay, ma'am. Okay, ma'am.
Any other?
Thank you, ma'am. We can have a break for 30 minutes, ma'am. Then we can
Okay.
start our second session at 11:30.
Yeah, sure.
Participants, kindly post your attendance for this session. The link is available in chat box, and also we posted it in WhatsApp group. So kindly post the attendance for all the sessions without fail, so that it will be easy for us to register your attendance for providing you the certificate. So thank you. Have a half an hour break. Join the session at 11:30.
Okay, ma'am. I will join by 11:25. Okay,
Okay.
na?
Okay, ma'am.
Thank you, ma'am.
Okay.
வந்து வந்துருக்கு